Before we get to example 1, let's take a look at the boxes up on the top. This says, let theta be an acute angle in a right triangle. And then we have some abbreviations. The first one we have is OPP, and that stands for the opposite side. Then we have ADJ, which is going to stand for the side that is adjacent to theta. And then we have HYP, which is going to refer to the length of the hypotenuse. So as we take a look at our triangle down here, this is our right triangle, and if you remember from geometry, this little box indicates that it's a right triangle. Here's our angle theta. So when we're looking at our angle theta, the side or the leg across from theta is called your opposite side. The side that touches that angle is the adjacent side. And the side across from the right triangle is our hypotenuse. Our trig functions can be found the following way, using what we call SOHCAHTOA. SOHCAHTOA means that we are going to let S stand for the sine of our function, and the sine of our function is going to be the opposite over the hypotenuse. So we use O for opposite, H for hypotenuse. Then we have the cosine. The cosine stands for the adjacent side over the hypotenuse. A for adjacent, H for hypotenuse. The T stands for tangent, and that tells us that our tangent is the opposite over the adjacent. O for opposite, A for adjacent. So one way that people use to remember these ratios is SOHCAHTOA. Now if we take a look at the cosecant, the secant, and the cotangent, what it says in this box below is that they are just reciprocal functions. So the sine and the cosecant are reciprocals. If you look at this is the opposite over the hypotenuse, and the cosecant is the hypotenuse over the opposite. Cosecant we usually write as CSC. Sine we usually write as SIN. Then if we take a look at the next one, cosine and secant are reciprocals. The cosine is the adjacent over the hypotenuse, where secant is the hypotenuse over the adjacent. Cosine we usually use just COS, and secant we use SEC. And then finally, our last reciprocals are the tangent and the cotangent. Tangent is the opposite over the adjacent, and cotangent is the adjacent over the opposite. For tangent, we usually just use tan, T-A-N, and cotangent, we use C-O-T. Scrolling down to the box underneath here, again, this is just reiterating the reciprocal functions. Another way to write the cosecant of theta is just 1 over the sine of theta, and so forth with these other two. And then again, your tangent of theta, we can think of as the sine over the cosine. And the cotangent we can think of as cosine over sine. So these are some relationships that you're going to have to know as we go through the chapter. Now let's take a look at example 1. In example 1, we have a triangle right here, and we want to find the sine, the tangent, and the cosine of x. So if we start with the sine of x, if we go back and think about SOHCAHTOA, the first part is SOH. S being for sine, so what we need is we need the opposite over the hypotenuse. So as we come to x, the opposite leg is going to be A, and my hypotenuse is going to be B. So the sine of x is going to be A over B. If I look at the cosine of x, so if I think again, we're going back to SOHCAHTOA. C stands for my cosine, so I have adjacent over hypotenuse. So I come to my angle. The adjacent leg is C, the one that's touching my angle, and the hypotenuse is still B. So I get the ratio C over B for my cosine. And then finally, we want to find the tangent of x. So let's finish this. We have SOHCA and then TOA, where T stands for tangent. And we want the opposite over the adjacent. So if this is our angle here, x, the opposite is going to be A, and the adjacent is going to be C. So we get A over C. Let's take a look at letter B. Letter B is using numbers instead of using all variables. One thing you have to note here is that we only have 2 of the 3 sides. So I want you to think back to geometry, to the Pythagorean theorem. The Pythagorean theorem relates the sides of a right triangle, and it says that a squared plus b squared is equal to c squared, where a and b are the legs and c is the hypotenuse. So we can use this formula in order to find our missing side length. We have both the legs, so we have a and b, but we're missing c. So a squared, we could do 8 to the second, which is 64, plus b squared, which would be 15 to the second, which is 225, equal to c squared. And then if we add 64 and 225, we'll get 289, equal to c squared. And to get rid of that exponent here, this 2, we can raise both to the 1/2 or just take the square root of both sides. And that gives us c equal to 17. And then I'm going to label that on my triangle so I remember that that side there is 17. And I'm going to come and finish up what I need. I need to find the sine, the cotangent, and the cosecant. So I'm going to start with the sine of x. And the sine of x, if I refer back to SOHCAHTOA, is the opposite over the hypotenuse. So I'm going to find my angle x. I want the opposite, which is 15, over the hypotenuse, which is 17. So the sine of x is 15 over 17. When I do my cotangent, so I don't have to memorize too much stuff, I'm going to use the tangent and the idea of the reciprocal to help me with the cotangent. If I know the tangent is the opposite over the adjacent, my cotangent is going to be the reciprocal of that. So it goes backwards. It's going to be the adjacent over the opposite. So when I come here, I'm looking at the adjacent, which is 8, over the opposite, which is 15. So cotangent is 8 over 15. And then I need the cosecant of x. I know the cosecant is reciprocals with the sine function. So if I take a look at my sine function, which is the opposite of the hypotenuse, I actually already have it. So if I know the cosecant is the reciprocal, I'm just going to flip it around, which is 17 over 15. Next, I would like you to do the try this, which is on the back. So I want you to find the tangent of theta. So just one function. So go ahead and pause it, unpause it when you're ready to check your answer. If you did this one correctly, you should have gotten the tangent of theta to be 12 over 5. If you have questions on any of this, please let me know.